Hello everyone, welcome back to my channel. So today I've come with a new video in physics and the name of the topic is electricity. So I've already made one video on electricity, that was the part 1, and today we are going to proceed with part 2 of electricity and I'm going to proceed with further details. Okay, and today's topic are based on class 9's current electricity. But before proceeding with electricity, I'm just repeating few things that I've already told you in the previous video. That is, what is electricity? When we are talking about electricity, then the first thing we need to keep in mind is its definition. So, electricity is a form of energy. Electricity is a form of energy. Like we have sound energy, we have heat energy, we have light energy. They all are a form of energy. Similarly, we have electricity that is also a form of energy. Now, they exist as charges in all atoms. So, they exist as charges in all atoms. Okay, so we have so many atoms. Okay, even each and every matter you can see around us is made up of atom, right? So every atom has its charge. Now what are these charges? These charges are basically your electrons. So electrons is present in all atoms. Therefore, these electrons constitute your electricity. Now concentrating into atomic structure a bit, AS, we have nucleus and electron orbits around it like this, and electrons are present in this way, right? So how they are held together, we know nucleus is positively charged and electrons are negatively charged. So we know opposite charges attract each other, therefore they are attracting each other. As a result, they are held together, they are bind together. But sometimes it is found that few electrons gets out of this attractive force and they comes out of the atom, and they are called free electrons and they constitute your electricity. Okay. Now coming to the types of electricity. What are the types of electricity? There are two types of electricity. One is static electricity, another is current electricity. Static electricity and current electricity. Static electricity is when electrons does not flow. Electron does not flow. They stay on objects. But current electricity, electrons flow. Okay, electrons flow and they do not stay on an object. Okay. Now in today's video, we are going to learn about current electricity and not about static electricity. Okay. I will not be covering each and every part in today's video. Okay. I will be speaking about few in today's video, and in the next video, I am going to proceed with the further one. So first of all, let us learn about the types of current. Current are of two types. Direct current, alternate current. Direct current abbreviated to DC, alternate current abbreviated to AC. Now, at first let us learn about direct current. When we are talking about direct current, then the first thing that we need to keep in mind is constant magnitude or constant flow of same magnitude of current in a particular direction. So constant flow of same magnitude of current in a particular direction. Okay. The order that I am following is according to my reference material. So as per my reference material, this is the definition of direct current. Okay. Or in a more shortened way, we can also say that direct current is the current of constant magnitude flowing in a direction. That means suppose X amount of current flowing in this direction, And if this is constant, this flow is constant, then that will result in your direct current. Now, what are the basic source of direct current? The basic source of direct current is cell. This is the basic source of direct current. Now, what are cells? What are your cells? Cells are basically the, a kind of a substance that provides us with direct current. Now, when we are talking about cell, they provide us current as a result of a chemical reaction. So, as a result of a chemical reaction, okay. So, in this way, they provide us with electricity. Now, as per the law of conservation of energy, what we know, energy can neither be created nor be destroyed. Rather, it can be transformed from one form to the other, right? So, here also we find that chemical energy getting transferred into electrical energy. Okay. Now, in case of cell, we have a vessel like this where two rods are immersed. Now, these two rods are called your electrodes and they are placed at the separation. These two rods are immersed either in a solution or in a jelly type substance. Either in a solution or in a jelly type substance, and this is called your electrolyte. This is called your electrolyte. Understood? Now coming to the types of cells. This is the structure of a cell. Okay? Coming to types of cells. Cells are of two types. Primary, secondary. If we are talking about primary cell, then the first thing that we need to keep in mind is the chemical reaction, that is chemical energy getting transferred into electrical energy, that is not possible here. Sorry, it's possible, but it is not reversible. Okay, it's possible, obviously it is possible, but here the chemical reaction is irreversible. But here it is reversible. Secondary cells are also called your accumulator, okay? Are also called your accumulator. Understood? Now coming to the primary cells, these cells provide current as a result of irreversible chemical reaction. The cells are discarded after use when the entire chemical energy in them has been used up. So therefore, they are use and throw types of cells. Okay, and depending upon the type of material of electrode and electrolyte, these two, the material, we have the types of primary cell. We have dry cell, we have simple voltaic cell, Leclanche cell, Daniell cell, and etc. Coming to secondary cells, here it also provides us with electricity as a result of a chemical reaction. But here the chemical reaction is reversible. That means chemical energy getting transferred to electrical energy, okay, and it is chargeable. They are not rechargeable, but they are rechargeable. So when we are charging it, then basically this is first. Second, when we are charging it, the electrical energy again gets back to the chemical form. So chemical energy gets restored, chemical gets restored, again the reaction takes place and again your electricity is produced. And this is found in our mobile phones. Okay, they are your secondary cells. But in case of your normal that we use in our remotes and all, they are your primary cells, they are basically your dry cells. So they are use and throw types of cells. And what are the types of secondary cells we have? We have nickel iron accumulator, we have lead accumulator, lithium ion batteries, and etc. Now coming to electric current. Coming to electric current. Now, when we are talking about electric current, then the first thing that we need to keep in mind is charge. What is charge? Like we have electrons, right? We have electrons. Charge is basically a unit. Okay? Not a unit, you can say it's a, like we have length, we have other things like the temperature and all. They are all your, you know, the fundamental ones that we basically use to express something. Okay, so charge is also similar to that things. So when we are talking about a charge, then the first thing that we need to keep in mind is the unit of charge. Unit of charge is coulomb. Charge represented by Q. Okay, unit of charge C, that is coulomb, represented by C. So I'm just reading out one thing once. Current is the rate of flow of charge across a cross-sectional area normal to the direction of flow of current. So this amount, the charge that is flowing, charge that is flowing per unit time is your current. Charge of one electron is 1.6 into 10 to the power minus 19 coulomb. Okay, so this amount of charge, okay, the amount of charge that is flowing in per unit time is your current. Clear? Now we have the amount of charge. Let it be your E. Okay, we have the charge of one electron, amount of charge of one electron, and we also have number of electrons. Suppose n number of electrons is flowing through a wire carrying E amount of charge, that is equals to this value. So can we say that the total charge equals to Ne? Obviously we can say, because number of electrons into charge of one electron, that will give you your total charge. So we can also say charge equals to Ne by T, because time is denoted by T, current is denoted by I, and Q is for charge. So Ne by T. Understood? Now coming to conventional flow of current. Suppose there are two bodies, A and B. Electrons are flowing in this direction. Okay, suppose electrons are flowing rightwards. Then current will flow leftwards, the opposite. Okay? Now coming to units of current. This was your conventional flow of current. Now coming to unit of current. Now we know current equals to charge by time. Is a unit of charges. Coulomb is a unit of time is second. So coulomb represented by capital C, time represented by S. Not time, basically second represented by S, that is a unit of time. Therefore current, which is represented by I, can be said current equals to C by C per unit second, or per unit second, not per second. Coulomb per second, so C by S. Understood? This can also be written as ampere. Okay, we can also say tell it ampere, represented by A. So SI unit of current is ampere, that is coulomb per second. Okay. Now coming to the two relations. What are the two relations? 1 milliampere represented by small m capital A equals to 10 to the power minus 3 ampere. Okay, this is the first. Okay, and 1 macroampere mu, macro represented by mu A, macroampere represented by mu A equals to 10 to the power minus 6 ampere. Okay. Now coming to now this was all about your current. Okay. Now coming to these things are very simple. Okay, I am telling you these are in details. So these things are going to be very simple. I'm not going in that details also, but necessary ones I am telling. Now before proceeding with symbols used in circuit diagrams, this is going to be our last topic for today. So, symbols used in circuit diagrams. Before that I am going to proceed with what is AC, alternate current. We are just going to know about the definition. Okay, nothing else. An alternate current is the current in an element, say a bulb, for which both the magnitude and the direction of current changes with time. The current repeats its value after a fixed time, and the number of times a current repeats its value in 1 second is called the frequency of alternating current. So basically, in case of DC, what we have saw, X amount of current, or we can say X ampere. We are now known to the units of current. So X amount of current flowing in any particular direction, and which if it is constant, then that will be your direct current. So AC is just the opposite. Here what we see is X amount of current is flowing in a direction, but that is not constant. This changes. This changes. And this particular thing is repeated after a certain interval of time. And that certain interval of time, or the amount of time it repeats itself after a certain interval of time, is called its frequency. Okay? Like in our mains, from where we draw electricity, the frequency is 50 hertz. Okay? That means because in our mains everywhere we have alternating current. So alternating current or alternate current or AC abbreviation means the amount of current and the direction in which the current is flowing that changes with time, and it repeats itself after a certain interval of time, and that is basically your frequency, the number of times it is repeating itself. So in case of our mains we find 50 hertz because SI unit of frequency is hertz, so 50 times it is repeating itself. Understood? Now coming to the symbols used in circuit diagram. Now the first thing is cell. First thing is about cell. Now first I have already told you about cells, right? How to represent cell in a circuit. Like this. We represent cell in a circuit. Okay? Longer side plus, smaller side minus, and like this we represent our cells. If you want to know about the basics, okay, then you may refer to my first video. Link will be given in the description. As well as if you want to know more about atomic structure, you may also search one more video which I have made on atomic structure. I'll give the link in the description for that also. So this is your cell. Now, what is your battery basically? Battery equals to cell plus cell, or more than one cells connected together in a series are your battery. So how to represent that? See, in this way. In this way we are going to represent. Okay. Now, how to represent? Now these are the sources of direct current. Now if it is an alternating current, how to represent that? AC can be represented in this way. Okay, we have a curving line like this, and this is the representation of AC or alternating current. Next, coming to key. A key or a switch. Basically, they are used for turning off and on the supply of electricity. Like we have turned off the fan. Okay, suppose we are turning off the fan or we are turning on the fan. That means what? If we are turning off the fan, then we are cutting the supply of electricity. As a result, it's turned off. But in case of fan turning on, that means what? We are pressing on the switch. Therefore, the circuit gets completed. As a result, electrons flow, electricity flow, fan starts working. So, How to represent a key in a circuit? Keys are of three types. At first, let us know that switch key, tapping key, or tap key, both you can say. And third is plug key. Okay, switch key, tapping key, plug key. How to represent a plug key? Plug key is represented in this way. This will be represent a plug key. Okay. How to represent a tapping key? Tapping key is basically represented in this way. We give an arrow. This is very important. This signifies your tapping key. If you miss that arrow, it will be your switch. That means switch is like this. Okay. But these are all when the keys are opened. These are all for open. Okay, when the keys are open, that means electricity supply is cut. Now if we want to say or draw closed ones, how to draw? In case of switch key, we will be drawing like this. In case of your tapping key, we have to draw like this. Okay. And in case of plug key, very simple, just we will put a dot in between. Okay. Now coming to the next one. Resistance wire, resistance box and rheostat. Okay. Basically, resistance wire are the wire that provides the circuit with resistance. I'll tell you what is resistance. Okay, at first let me tell you that. Resistance wire are the wire that provides the circuit with resistance. Resistance box are basically the box, okay, where we have a fixed number of resistance. Okay, there are key type something attached. If we are plugging out the key from that resistance box, then basically we can have the supply of resistance. And in case of rheostat or variable resistance, basically we can vary the resistance. We have a jockey there. You can see pictures in Google also. So we can adjust the jockey and reduce or increase the amount of resistance. Okay. Basically in case of a rheostat, we have asbestos pipe like this, where wires are rolled. Okay. Very adjacent to each other, they are rolled. And we have a jockey over here. And this side we have one connection, and this side we have one, and this side we have one. So if we are connecting the wires to A and B, that means the fixed amount of resistance that this is having it will be facing. But if we are connecting one with A and another with C, or one with B and another with C, then basically we can adjust the jockey, and as a result we can adjust the resistance, increase or decrease the resistance. Okay. Because if we are just applying, means connecting with A and B, that means what? The electrons will go, it will travel like this and it will move out from B. But in case of A, in case of A and C, it will enter from A, move like this, and then from here it will move. Okay, means till the portion where the jockey is attached, till that portion it will travel, that will give it its resistance. Then what will happen? The electrons will get up to the jockey, and through this conducting material, it will move out from C. Okay. Now how to represent the resistance? Normal fixed resistance are represented in this way. But if we want to represent rheostat, then how to represent that? First we will draw resistance. This will be our A, this will be our B, and we will be drawing an arrow like this. Okay, and this will be our C. And same concept, if we want to continue from A and B, the fixed amount of resistance it has to face. Or if we want to change the resistance, then we can do it from here. So we will have a change in the resistance, or we can adjust it according to ourselves. Okay. Now coming to the next topic, that is ammeter. When we are talking about ammeter, then it's used for measuring the amount of current flowing in a circuit. We have an arrow. Okay, we have an arrow like this. On the amount of current, we have Okay, I'm drawing it here. We have an arrow like this and we have the numbers written. And as per the amount of current, the arrow moves, and we, as per the numbers, we will find that how much current is flowing. Okay. How to represent ammeter? We represent ammeter in this way. Write A, circle it, and two wires. In case of your voltmeter, next topic is our voltmeter. Voltmeter is used for measuring potential difference. What is potential difference? I'll tell you in my next video, which is going to be the part 3 of electricity. Because this is part 2. Earlier I've already made part 1. So in my next video, part 3, I'm going to explain you what is potential difference. But for the time being, know that voltmeter or V is used for measuring the potential difference. Okay, and it is represented in this way. It is also like this, having an arrow, and as per the amount of potential difference, the arrow deflects, and as per the number, we find out how much potential difference or volt is there, because the unit of potential difference is volt. Understood? Now coming to galvanometer. Now galvanometer is used, basically the arrow is placed at the center. Galvanometer can be used for two purposes. First, detecting the direction. Second, presence of weak current or very weak current also you can say. Very weak current. Okay. So it has an arrow like this and we have the numbers written. So if there is a little bit deflection in the arrow also, we will know that current is there, which is not detected by ammeter. Ammeter cannot detect small amount of current. Very weak current cannot be detected by ammeter, but galvanometer can do. So it can, if the arrow deflects, we will find that there is the presence of electricity in the circuit. And if the arrow moves this-ward, then we will say that means the direction in which the arrow will move, either this side or this side. As per that, we will understand that what is the direction of flow of current or what is the direction of flow of electrons. We can say that also. Now coming to the last one, that is the load. Loads are nothing. Basically, they are nothing, but they are the appliances that are added to the circuit. Bulb, fan, heater, etc. Heater, it is represented like this, resistance, and just like this. But it has no connection with resistance. Don't confuse yourself. Resistance is drawn like this, but heater is represented like this. Okay? So it's my request not to confuse yourself. Now, how to represent a bulb? Bulb can be represented in three ways. First, like this. Second, like this. And third, like this. Now, third one we do not use much. Sometimes it is usable, but most probably we use the first two. Either this or this. Now, if there is, suppose, means the connection is cut in the bulb, then we have to represent it in this way. Okay, in this way we have to represent. And suppose the bulb is glowing, then we have to represent it in this way. And suppose the bulb is okay, but the bulb is not glowing, that means we have to represent it in this way. Okay. Coming to the connecting wires are nothing. These lines, which is joining the bulb and everything. These lines are your connecting wire. Because practically, if we want to do it, it will be through connecting wires. I'll give the link of my practical video also where I have made simple circuits. Okay, I'll give that link also. And in my next video, I will show one more thing using multimeter. Basically, your ammeter, voltmeter, these all are separate instruments. But nowadays, we find one more kind of instrument where all the things are given at once. Or rather, all these characteristics, all the instruments are placed only in one instrument. So I have multimeter. I will be making a video on that. Or in my next video only, I will at first complete with my next objective and then I'll proceed with our multimeter. Okay, simple, practical, but I'll show you. Now coming to simple electric circuits. Now I've already in my previous video I've told you what are the types of circuit. So we have parallel circuit and series circuit. Okay, today I'm only showing you parallel using all these symbols. Now, first for drawing a simple circuit, we have the connecting wires. At first we are connecting the bulb like this. Then we are connecting the cell. Okay. Then I'm going according to my diagram. Then we are connecting ammeter. Okay. Then, okay, ammeter I am just drawing it later. First, let me add rheostat to it. Okay, I am connecting it with C and not with B. Make sure, okay, this is your A, this is your C. I'm connecting with C and not with B, because I want to give the circuit my variable resistance. Now here let me add your ammeter. It will come down like this. Okay, and here we can also add one more bulb if we want, but I am not adding. Now from here we have to add our volt. Now these all are in series, but this is in parallel. Why? Because without parallel the potential difference will not be there. I'll tell you what is potential difference. Wait for my next video. But when we are talking about volt or voltmeter, if we are connecting, because we need to measure the potential difference, it has to be connected in parallel. Otherwise, potential difference wouldn't be there if it is in a series. Okay. Now I'm just reading out that one simple thing for open and closed circuit. For an electric circuit to be complete, each component of it must pass current through it. Okay, that means it must be conducting. If suppose there is a little breakage like this, then it is a open circuit. Electrons cannot flow. This appliance, that is the bulb, will not glow. Okay, as I'm not connected a key over here, so I'm just adding a plug key. Okay. So this circuit consists of ammeter, bulb, your cell you can also give this information, your rheostat, plug key, voltmeter. Okay. So this was all for today. Hope you have liked my video. If you like my video, please like, share and subscribe it. Also press the bell icon to get the notification of my uploaded video. In my next video, I am going to complete rest of the part and show you multimeter. Okay. Till then, bye.